Hello everyone. Today I am going to start Unit 2 Solution chapter in new lesson. So the term solution means homogeneous mixture of two or more than two components. So when the constituent of the solutions are two, constituents of the solution are two, that means two component system, then it is known as binary system. Binary. If three constituents are 3 or components are 3, then it is known as ternary. If it is 4, then it is known as quaternary, and so on. In binary system or in binary solution, two constituents of the solution are solvent and solute. In this chapter mainly আমি binary system binary solution or binary system discuss করি. So different types of solution. So gaseous solution, liquid solutions, solid solutions. So gaseous solution, liquid solution, solid solution. Uh, Gaseous solution means when the solvent is gas, then it is gaseous solution. When the solvent is liquid, then it is uh, liquid solution. When the solvent is solid, then it is known as solid solution. Now your solute may be gas, liquid or now gaseous solution mixture example is mixture of oxygen and nitrogen gases and gaseous solution that is solute is liquid that is chloroform is liquid and it is mixed with nitrogen gas then it is again a gaseous solution liquid in gas camphor which is solid in gas that is nitrogen gas. Next is example is liquid solution example. Gas in liquid that is oxygen dissolved in water is an example of gas in liquid. Similarly liquid in liquid that is ethanol dissolved in water. Solid liquid glucose is solid dissolved in water. Next one is solid solution that is solvent is solid. So when gas is dissolved in solid. So solute is gas, solvent is your solid. So A2 example that is solution of hydrogen in palladium. Solution of hydrogen in palladium. Hydrogen in palladium that is if you remember then these are the catalysts nickel, hydrogen, nickel, palladium, platinum, hydrogen gas on nickel, platinum, palladium surface. They are reducing reagent. So this is an example of your solid solution. So solution of hydrogen in palladium. Next example is liquid amalgam of mercury. Mercury is liquid with sodium that is solid. Next example is solid. Copper dissolved in gold is an example. Both copper and gold solid. So this is an example of solid solution. Now there are different methods of expressing the concentration of solution. Okay. So different methods ভিতৰত কেইটামান মেথড আমি অলৰেডি ফাৰ্ষ্ট ইয়েৰত আমি পাইছোঁ ন নৰ্মেলিটি মোলাৰিটি মোলালিটি এইবিলাক টাৰ্ম আমি আগতে পাইছোঁ দিজ আৰ দ্য ৱে টু এক্সপ্ৰেছ দ্য কনচেন্ট্ৰেশ্যন অফ সলিউশ্যন so concentration of the solution can be expressed in terms of molarity molality mole fraction এইকেইটা টাৰ্ম আমি আগতে পাইছোঁ now এতিয়া আমি ডিসকাস করি মেথড অফ এক্সপ্রেসিং দ্য কনসেন্ট্রেশন অফ সলিউশন ফার্স্ট ইজ mass percentage means that is in 100 so mass percentage means weight by weight that may be defined as the mass of the solute per 100 gram of the solution that means the amount of solute dissolved in 100 gram of the solution then it is known as mass percentage. So if I say that 10% glucose in water by mass that means 10 gram glucose present in 100 gram solution. So 10 gram glucose present in 100 gram solution. That means amount of solvent is your 90 gram, because solute plus solvent, that is solution, is equal to 100, because mass percentage means mass of the solute per 100 gram of the solution. So this is very important. 10% glucose in water by mass means 10 gram glucose dissolved in 90 gram of water. Resulting solution is your 100 gram. Okay, and mass percentage of solute আমি কেনেকে এক্সপ্রেস করো, mass percentage is equal to mass of the solute divided by total mass of the solution into 100, that is percentage. Now, so next is volume percentage, that is volume by volume. It may be defined as the volume of solute per 100 ml of solution. Volume of solute, that is volume of solute in 100 ml of the solution. Total volume of the solution is 100 ml. Very, very important one. So, if I say 10% ethanol solution in water, means 10 ml of ethanol dissolved in water. Okay, and the total volume is 100 ml. That means 90 ml water is present, 10 ml ethanol, and the solution is 100 ml. And volume percentage of solute, it is expressed as volume of the solute divided by total volume of the solution into 100 in percentage. Next is mass percentage. Mass by volume percentage. Mass by volume, that is weight by volume. It may be defined as the mass of solute per 100 ml of the solution. So mass solute আমি measure করিম in gram, and in solution or কেনেকে measure করিম in ml. Then it is known as mass by volume percent. So mass by volume percent, mass of the solute divided by volume of the solution into 100. That is percentage. Next is parts per million. So like percentage, parts per million. That means million means 10 to the power 6. So it is the parts of the component per million parts of the solution. So like your percentage, যদি percentage 10% বুলি কওঁ, 10% by mass বুলি ক'লে 10 gram solute dissolved in 100 gram of the solution. Okay, so similarly ইয়াত 100 ৰ ঠাইত কি আহিব, 10 to the power 6, that is per million. Okay, so parts per million, it is expressed as number of parts of the component divided by total number of parts of all the components present in the solution into 10 to the power 6. This in parts per million, na? So it is 10 to the power 6. So if it is percentage, then it is 100. As it is parts per million, that is 10 to the power 6. So ppm, it is also can be expressed. So parts means we can express it in terms of mass also. ppm, mass of the solute divided by mass of the solution into 10 to the power 6. Okay, that is parts per million. And this ppm unit is generally used when the solute is present in less amount. Okay, generally contamination of water, it is water is contaminated by some carcinogenic components. Okay, so this type of small amount যদি trace or small amount of solute is present in large excess of solution থাকে, then we use the term ppm. Okay, next is mole fraction. So mole fraction, this term is we are actually familiar with this term mole fraction. It may be defined as the ratio of the number of moles of the component, solute or solvent to the total number of moles of the component present in the solution. So in this chapter, basically we deal with only binary system. The binary system basically আমি এইটো chapter discuss কৰিম. So ইয়াত আমি binary system হলে component কি হ'ব? Two component system. So let us consider, if we consider Na and Nb are the number of moles of solvent and solute. Okay, so in a solution, Na is the number of moles of solute, Nb is the number of moles of solvent. Then mole fraction of solvent A in the solution, it is expressed as mole fraction Xa. Mole fraction Xa, that is for your solvent, is equal to number of moles of the solvent divided by total number of moles present in the solution. Total number of moles, as it is a binary system, so two components A and B, so Na plus Nb. Similarly, mole fraction of the solute B in the solution, it is expressed as Xb is equal to Nb divided by Na plus Nb. And again we know the sum of mole fraction of all the components is equal to unity. So in a solution, jiman number of mole thakok, mole fraction or summation to ki hobo? Always 1. So in a binary system, আমি discuss করি আছো না, two component system, binary system. So in this binary system, so two components are there. One is solvent and another is solute. So Xa plus Xb is equal to 1. Two components. So let us discuss one problem based on this mole fraction. Calculate the mole fraction of ethylene glycol. Ethylene glycol, it is dihydric alcohol, দুটা OH থকা. So actually it is CH2OH, CH2OH. Okay, dihydric alcohol. So so formula is already given, so structure is not required here. So ethylene glycol in a solution containing 20% of ethylene glycol by mass. Okay, so we have to calculate what? Mole fraction of ethylene glycol. So 20% of ethylene glycol by mass means 20 gram ethylene glycol dissolved in ethylene glycol solution dissolved in 80 gram of water. Okay, given the mass of ethylene glycol is 20, so it is already given 20 gram. So mass of water, it is 80 gram. And again we know molar mass of ethylene glycol, if you calculate, you will get 62 gram per mole. Again we know molar mass of water, it is 18 gram per mole. So we have to calculate mole fraction of ethylene glycol. Okay, so using the formula, mole fraction of ethylene glycol is equal to number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water. Okay, so number of moles of ethylene glycol, that means number of moles we know, mass divided by molar mass. So number of moles of ethylene glycol means mass of ethylene glycol divided by molar mass. So mass of ethylene glycol, it is your 20. Mass is 20 given. Molar mass, if you calculate, you will get 62. So is equal to 0.322 mole. Okay, number of moles. Next, number of moles of water. Now, number of moles of water, mass of water divided by molar mass of water 80 gram and molar mass 18, so 4.4444 mole. Okay, so using the number of moles of the value of number of moles of ethylene glycol and number of moles of water, and using the formula mole fraction of ethylene glycol is equal to number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water, putting the value and calculating mole fraction of ethylene glycol is 0.068. Okay, so mole fraction of ethylene glycol is this. Okay, so similarly, if you want to calculate the mole fraction of another component, then no need to calculate all this, because we know summation of mole fraction is 1. We know the mole fraction of one component. So mole fraction of water 1 minus mole fraction of ethylene glycol. So value is 1 minus 0.068. So it is 0.932. So A to water to calculate koribole diya nai, but ami enake calculate koribo paru. So next is your molarity. So we are already familiar with this term molarity. So molarity means it is defined as the number of moles of solute dissolved in 1 liter of solution. It is defined as the number of moles of solutes. So number of moles of solute divided by volume of the solution in liter. So molarity is moles of the solute divided by volume of the solution in liter. Okay, so number of moles means moles of solute means mass of the solute divided by molar mass of the solute. Mass of the solute, we can use the symbol WB, mass of the solute divided by molar mass of the solute into 1 by volume in liter. Okay, so molarity, so molar mass of the solute jodi ami use koro symbol capital MB and volume V. So in ml, when it is in ml, then we have to multiply this by 1000. Okay. Now here WB, mass of the solute in gram, MB, mass molar mass of the solute, V, volume of the solution in ml. So here the V is the volume of the solution in ml. If we use this 1000, okay, so 1000 যেতিয়া আমি divide কৰিছো volume divided, that means liter to আমি ml লৈ convert কৰিছো. so এইটো নকৰাকে তোমালোকে direct volume in liter ৰাখিব পাৰা, no problem. Okay, so molarity, unit of molarity is number of moles, unit is mole divided by volume, so mole per liter, or capital M, or is known as molar. Okay, now molarity changes with temperature. Okay, as volume change with temperature, so molarity is temperature dependent. So as molarity depend করে কার ভলিউমের উপর, ভলিউম টেম্পারেচার চেঞ্জ হলে ভলিউম চেঞ্জ হয়, so molarity is temperature dependent. Next is molarity, molality, small m. So it is defined as the number of moles of the solute dissolved in or dissolved per kg of the and it is the number of moles divided by mass of the solvent in. So moles of the solute divided by mass of the solvent in kg, molality. So molality, number of moles by mass of the solvent in gram. If you write, then you have to multiply by 1000. That means আমি কি কৰিছো kg in kg যদি গ্রামত দিয়া থাকে তেতিয়া multiply কৰিব লাগিব 1000. That means যদি কোৱেশ্যনত মাছটো দিয়া আছে গ্রামত, তেতিয়াহ'লে আমি কেজিলৈ কনভাৰ্ট কৰিব লাগিব। চ' ডিভাইড কৰিলে ওপৰতকৈ মাল্টিপ্লাই হৈ যাব। চ' molality can also mass, molality number of moles, no? Molarity is number of moles. Number of moles means mass by molar mass. So WB mass of the solute, MB molar mass of the solute, WA 1000. So WA is the mass of the solvent. Okay, so WB mass of the solute in gram, molar mass of the solute, and WA mass of the solvent in gram. So multiply কৰিছো 1000. So যেতিয়া আমি 1000 লিখো তেতিয়া এইটো আমাৰ কি হ'ব, গ্ৰামত হ'ব। Okay, আৰু যদি কেজিত থাকে তেতিয়াহ'লে 1000 টো আমাৰ নালাগে। You can use directly this formula also. So unit of molality is, so number of moles divided by mass of the solvent in kg. So unit is mole per kg. And molality is temperature independent, as mass, number of moles by mass of the solvent. So it is temperature independent, but molarity is temperature dependent. Okay, so এতিয়া মই এটা নতুন ফৰ্মুলা ইয়াত ইউজ কৰি আছো, কৰিবলৈ গৈ আছো। So this is your dilution formula বুলি ক'ব পাৰা। So if V is the molarity of V1 ml of molarity M1. Okay, তাৰমানে given solution volume দিয়া আছে, volume is provided, volume is V1, molarity is M1, and the solution is diluted to volume V2. তাৰমানে solution V1 টোক মই dilute কৰিছো up to V2. Okay, V2 লৈ dilute কৰিছো, dilute means solvent add কৰিছো, so dilute কৰিলো. Then how to calculate the molarity of the dilute solution? If I express the molarity of the dilute solution by M2, then remember the molarity equation will be M1 V1 M2 V2 for dilution from volume V1 to V2. Okay, so yat moi consider korisu M1 V1. So this part, left hand side, that is given solution or karone. Okay, and right hand side, jitu solution ami diluted solution or karone. Okay, diluted solution or karone or unknown solution or karone, concentration or karone ami use koribo paro. So using this formula আমি numerical solve কৰিব পাৰিম। এইটো base মই numerical এটা solve কৰিছো, আমি discuss কৰিম এতিয়া। Okay, so M1 V1 M2 V2. So এইটো formula important হয়, এইটো তোমালোকৰ practical তো লাগিব। So V1 S1 কেতিয়াবা আমি চাবা M1 ৰ ঠাইত S1, that is strength হিচাপত আমি use কৰো, volume into strength is equal to again volume into strength। দুটাৰ বেলেগ বেলেগ concentration or dilution or karone enaka formula use koro, V1 S1 V2 formula use koribo paro। M1 or ঠাইত S1 represent strength, S2 represent strength of the diluted solution। Okay, so আমি এতিয়া mainly dilution or karone kuntu formula use korim, strength or karone M1 V1 is equal to M2 V2। So let us try this one. Calculate the molarity and mole fraction of potassium iodide. Okay, and density of 20% mass by mass aqueous potassium iodide is 1.202 gram per mole. Okay, so by mass, that means 20 gram potassium iodide dissolved in 80 gram water, aqueous solution. Okay, 80 gram water. So first you have to calculate molality. So 20% mass by mass aqueous potassium iodide means, so I already calculated 20 gram potassium iodide dissolved in 80 gram of water. So 20 gram dissolved in 80 gram of water. So given mass of solute that is 20 gram. Mass of solvent, that is 80 gram. Mass of the solution is 100 gram. Solute plus solvent, it is 100 gram. Density of the solution, potassium iodide, is 1.202 gram per mole. And molar mass of the solute Mb, potassium, is 39, iodide is 127, that is 166 gram per mole. Okay, so first A molality calculate koriম using the formula WB by MB 1000 into 1000 divided by WA, that is mass of the solvent in gram. So value just put kori diso. Mass of the solute, it is 20, molar mass 166, and mass of the solvent, it is 80 gram. So after calculating, we'll get 1.5 mole per kg. Next one is we have to calculate molarity. So if you remember, molarity is number of moles divided by volume of the solution in liter. Okay. So volume of the solution, it is not given, mass of the solution is given. So volume, how to calculate the volume of the solution? Mass of the solution divided by density of the solution. So divided by density, mass of the solution is 100 gram, density 1.202 given. So mass by density calculate 83.195 ml. Okay. Now using the formula, this molarity is equal to WB by MB into 1000 by V, and V is now in ml. So putting all the values here and just calculate 20 mass of solute, 166 molar mass, volume of the solution is 83.195. So molarity is 1.45 mole per liter. Okay, next you try to solve this mole fraction of potassium. এইটো solve কৰিবলৈ try কৰিবা. Mole fraction or eta numerical মই কৰি দিলো নহয়. So you just calculate number of moles of water, number of moles of potassium iodide, and try to solve. Okay. Next, calculate the molarity of each of the following solution. Next problem, number 1, 30 gram of 30 gram of, I missed this one, 30 gram hobo, 30 gram of cobalt nitrate hexahydrate in 4.3 liter solution. Okay, 30 gram. Okay, and next one is 30 ml 0.5 molar H2SO4 diluted to 500 ml. Okay, so atomic mass of cobalt, it is 58.7. So solution, mass of the solute, first one mass of the solute, it is actually 30 gram. So G2 yat more meets hoigol, so you just write mass of the solute 30 gram. So volume of the solution or volume given 4.3 liter. And molar mass you calculate molar mass of the complex cobalt nitrate hexahydrate. Cobalt is 58.7 and nitrogen 2, so 14 into 2. Then your oxygen 16. Oxygen, how many oxygen atoms are there? 6, 12. So 12 into 16 plus how many hydrogen? 12 hydrogen. So after calculating, you will get 290.7 gram per mole. You just add the molar mass of each atom. So using the formula molarity, so yat my volume to liter of loisu, no? So it is given in liter, so no need to multiply here by 1000 to আমাৰ ইয়াত নালাগে তেতিয়া ভলিউমটো আমি লিটাৰত লওঁ so just put the values here so molar 30 gram divided by molar mass 290.7 1 by 4.3 so 0.024 mole per liter okay molality molarity okay so this is molarity not molality molarity r huh? So this is r so given volume of the solution of the given solution sulfuric acid given solution v1 30 ml molarity of the given sulfuric acid solution m1 it is 0.5 molar 0.5 molar it is given okay and volume of the diluted sulfuric acid it is diluted to 500 ml okay and you have to calculate the molarity of diluted sulfuric acid that is m2 now just using the dilution formula that is m1v1 m2v2 so all the values are known just you calculate out m2 putting the values so you will get 0.03 molar so m2 is 0.03 so next problem a sample of drinking water was found to be severely contaminated with chloroform which is supposed to be carcinogen. The level of contamination was 15 ppm by mass. Okay, so contamination, water pollution, that means chloroform amount is less. It is present in water, which is carcinogenic, that is cancer causing. The level of contamination is this by mass. So you have to 15 ppm by mass, that is 15 gram. Okay, 15 gram chloroform in 10 to the power 6 grams. So express this in percent by mass. So it is in ppm is given. You have to express it percent by mass. Determine the molality of chloroform in water sample. So it is ppm na 15 ppm, that is 15% বুলি ক'লে আমি কি গম পাওঁ 15 gram in 100 gram 15 gram in 100 okay 15%, that is 15 in 100 so ppm means 15 gram in 10 to the power 6 gram so let the mass of the solution is 10 to the power 6 gram that as it is in ppm so mass of the solute that is chloroform 15 gram over 15 ppm okay so percentage by mass of chloroform mass of the solution into 100 so mass of chloroform 15 mass of the solution it is 10 to the power 6 into 100 so 15 into 10 to the power minus 4 okay next part is mass of the solvent mass of the solvent WA is equal to 10 to the power 6 gram minus 15 gram 10 solution minus solute so this is approximately 10 to the power 6 so 10 to the power 6 gram minus 15 gram approximately 10 to the power 6 hobo okay so mass of the solvent is 10 to the power 6 next molality you have to calculate so molality mass of the solute divided by molar mass 1000 by mass of the solvent in gram now put the values okay for this you have to calculate molar mass of mb molar mass mb of chloroform that is chloroform carbon 12 hydrogen 1 chloroform 3 into 35.5 it is 119.5 so molality is 15 divided by 1.95 into 1000 by 10 to the power 6 so 1.26 into 10 to the power minus 4 mole per kg Thank you.